So far, we talked about orthogonal projection. Now, if you have a set that has pairs of vectors perpendicular to each other or orthogonal to each other, we say that, hey, S is orthogonal set. If each vector in S is also a unit vector, you call S orthonormal. Why it is important? Because we can define orthonormal bases for different vector spaces. For example, let V be the space. I'm going to define S to be this set. I have 1 over square root of 2, 1 over square root of 2, and 0. The second vector is negative square root of 2 divided by 6. You have square root of 2 divided by 6, and you have 2 square root of 2 over 3, and the last vector is 2/3, negative 2/3, and 1 over 3. We have 3 vectors here. V1, V2, V3, very good. Is set S orthonormal? Check. First, check V1 is perpendicular to V2, V1 is perpendicular to V3, and V2 is perpendicular to V3. So these are perpendicular ones. It means that if you find a dot product between them, it must be equal to 0. Or V1 dot V2 0, V1 dot V3 is 0, V2 dot V3 is 0. You're checking this. So here, if you multiply these two, you get negative 1 over 6. And here you have plus 1 over 6 plus 0, which is 0. So V1 is perpendicular to V2, or they are orthogonal. V1 and V3. So here you have 2 divided by 3 square root of 2 minus 2 divided by 3 square root of 2 plus this is just 0. Basically, it is 0. So these two vectors are also orthogonal or perpendicular. The last two pairs are V2 and V3. If I multiply these two together, what I get negative square root of 2 times 2 divided by 18. And here, if I multiply these two, I get negative 2 square root of 2 divided by 18, and multiplication between these two plus 2 square root of 2 divided by 9. So if I add these two together, it is negative 2 square root of 2 divided by 9. So the sum is 0. These two are also orthogonal. So far, S is an orthogonal set. Now, to show that it is orthonormal, S is orthonormal, and we need to check the norm size or magnitude of each vector. Okay, so for vector 1, it is square root of 1/2 plus 1/2 plus 0, which is square root of 1 or 1. V1 is a unit vector. What about V2? V2 is the square root of 2 over 36 plus 2 over 36 plus 4 times 2, 8 over 9. So let's see. We need to take common denominator between these two, or we can simplify this. So here you get 2 divided by 36, or 1 over 18, 1 over 18. So 2 over 18, 1 over 9, square root of 9 over 9, or square root of 1, which is 1. You can check the magnitude of V3 as well. V3 is also a unit vector. Here you have 4 over 9 plus 4 over 9 plus 1 over 9, which is basically 1. So each vector in S is a unit vector. So it is orthonormal set.